Welcome back to the Deep Dive. Today, we are getting into one of the most immediate and frustrating problems for anyone building with LLMs
Oh, yeah.
that struggle with accuracy, with understanding, and, the constant problem of hallucination.
hmm
If you're building on systems like GPT-4, Claude, Llama, you are using traditional retrieval augmented generation.
Yeah, merit. And if you've done any serious work with it, you know that traditional RAG is it's hitting a hard strategic ceiling.
It's so true. We're sort of stuck in this pattern where we treat the LLM like this, I don't know, a passive knowledge box. We just dump these huge raw passages at it,
Yeah.
like 10 dense paragraphs of technical docs, and we just hope for the best.
And that approach completely misuses what the model can do. It leads to, a really superficial understanding because the LLM is basically just skimming.
It's trying to do too much at once.
Exactly. It's trying to perform this complex reasoning on raw, noisy information, and that's why hallucination rates stay so stubbornly high, especially in these really specific applications where you can't afford to be wrong.
So what we need is a total shift in how we think about this. The goal can't just be more data. It has to be about enabling active learning.
Right.
And the blueprint for that seems to be this new framework called ActiveRAG.
And this isn't just a theory.
No, we've got validated results. We're talking an improvement of over 5% on these critical question-answering data sets compared to the old passive models.
And, that 5% might not sound huge, but it's the difference between a cool tech demo and something you can actually deploy with confidence. It's a real high reliability solution.
Yeah.
It forces us to stop tweaking things and start thinking about a fundamental change in the architecture.
So our mission today is to unpack the theory behind this and then walk you through the 3-step playbook for how to actually do it.
Right. Knowledge construction, dynamic retrieval, and then the cognitive nexus.
And we're going to frame this specifically for tools you can use right now, like CustomGPT's or assistants. We'll show you how to structure knowledge so the LLM actually learns.
Okay, so let's start with where passive RAG really fails. The problem is actually quite simple. It's noise amplification.
Noise amplification.
Yeah, think about it. If you retrieve 20 random documents, and even a few of them are irrelevant or they contradict each other, you've just made it way more likely the model will get confused.
It's like you're trying to teach a student by just throwing a textbook, a blog post, and a flyer at them all at the same time.
Exactly.
So the answer isn't just better retrieval, it's better ingestion, better processing.
That is the core insight. ActiveRAG's success is actually rooted in something called constructivism theory.
Which isn't even an AI concept, right?
Not at all. It's a theory of learning from, education, from pedagogy. It basically says that a learner, in this case the LM, actively builds new understanding by connecting external knowledge to what it already knows.
Can you give us an analogy? How does that work in the real world?
Sure. Think about a corporate training program. If you're training new engineers on some super complex system, you don't just hand them the advanced troubleshooting manual on day one.
Right, of course not.
You start with a glossary of terms, the operating principles, the foundational safety stuff. You build up that required context before you throw complex scenarios at them.
So that foundation lets them absorb the new dynamic information way more effectively.
You got it. The LLM shouldn't be starting every single query from scratch or just relying on its, often outdated pre-trained knowledge. It needs these engineered prerequisites.
Which leads to the big deployment strategy here. The best RGA systems aren't about clever prompt engineering.
No, not anymore. They're built on engineered knowledge structures. We have to transform that raw, messy domain information into what we call purpose-built cognitive assets, things that actually guide the LLM's reasoning.
And that takes us right to step 1, knowledge construction.
Yeah.
This is where we stop dumping raw text and start using these highly structured preparatory documents. You call this static context augmentation.
Yes. So we pre-process the really critical foundational domain knowledge into 3 distinct structured foundation documents.
And these are static.
Completely static.
Yeah.
They provide the context and understanding before any real-time information retrieval even happens. They act like little specialized agents, and each one addresses a specific failure point of the base LLM.
Okay, let's get into those. What are these 3 agents and what do they actually do?
So the first is for epistemic anchoring. We call it the anchoring agent. Its whole job is to establish that foundational understanding.
So the basics.
Exactly. We feed it content that is probably unfamiliar to the base model. Think specialized glossaries, proprietary company terms, internal project names, key background concepts. It's the must-know prerequisite knowledge.
Okay, so if I'm building this for a law firm, the epistemic anchor would have all the niche state-level case law jargon that a huge model like GPT-4 might have just missed or gotten wrong.
Spot on. The second is for logical reasoning, and that's handled by the logician agent. LLMs are, they're decent at inference, but they can really struggle with complex cause and effect chains, especially in a specialized field. So this document structures information to define those clear causal relationships.
Like what? Flowcharts.
Yeah, things like structured decision trees, regulatory flowcharts, sequences of operations, validated if this then that statements. It's all about the how and the why of a process.
Which is often way more complex than just the what.
Absolutely. And then the third, and this one is probably the most crucial for stopping errors, is cognitive alignment. This is handled by the cognition agent.
And this is the one that really tackles the model's own biases.
It's the hardest worker. It contains authoritative data specifically designed to update, correct, or even refute knowledge that might contradict what the model thinks it knows from its original training.
Okay, hold on. I have to push back on this a little. Isn't engineering 3 different documents just a lot more work? It sounds like triple the effort.
That's a fair question. It is more upfront work, but the difference is strategic. With old school RAG, you're constantly re-engineering your prompts and your filters for every little use case, and you still don't fix the model's core confusion.
Right.
With ActiveRAG, you invest that effort once in these static cognitive assets. Then they serve as this reusable foundational intelligence for all queries in that domain. It actually makes your dynamic prompting way simpler and gives you much better quality control.
Okay, that clarifies the return on investment. So let's go back to that cognitive alignment agent. How does it handle real-world messiness? The paper mentioned an example with the woods. Can you make that concrete for us?
Definitely. So imagine your knowledge base has information about the 2006 horror film The Woods, but it also has information about a producer named Robert Woods.
Okay, I can see where this is going.
A passive RG system retrieves 10 documents. Some are about the film, some are about Robert Woods getting a new job. The LLM sees both terms and is really prone to what we call model illusion. It just blends them together.
And it spits out with total confidence that Robert Woods produced the film, which is wrong.
Exactly. The cognition agent stops that. It contains structured, authoritative data that explicitly says the film The Woods is a distinct entity from the producer Robert Woods.
So it forces a fact check.
It forces a factual check based on an engineered source of truth. It makes the model realign its answer, even if the raw data it just retrieved was ambiguous. It's like the model's internal, specialized fact checker.
That is a brilliant layer of discipline. So we've built this solid static foundation in step 1. Now, how does the system deal with, real-time information? Let's get to step 2, dynamic action, the retrieval stage.
Because the LLM has already absorbed all that foundational intelligence from step 1, step 2 can be really strategic and efficient. The ability to pull in current information is implemented by defining RAG, not as some default search, but as an API-driven action within a custom GPT or assistant.
Why is that distinction so important, making it an explicit action?
Because it adds accountability.
Yeah.
It turns ARGA from this messy, always-on thing into a tool that is used deliberately. And the strategic reason is optimization. Research shows that because the static context works so well, the system performs almost identically, whether it uses the top 5 or the top 10 retrieve passages.
Meaning the static foundation is often good enough on its own.
A lot of the time, yes. So we can reserve that dynamic ARG action only for when it's absolutely needed.
That's a huge deal for cost and speed. You preload the intelligence, and the expensive retrieval engine only kicks in if the model realizes it has a knowledge gap.
Exactly. It's about being smart with your resources.
Okay, which brings us to the final piece, the conductor of the orchestra. Step 3, crafting the prompt, which creates what you call the cognitive nexus.
The nexus, yes. This is where we bring it all together. The LLM, the static documents, the dynamic action into one disciplined pipeline.
And how do you enforce that?
It's all enforced through a very detailed initial instruction set, a meta prompt. This prompt doesn't just ask a question. It defines the mandatory process the LLM has to follow to get to the answer.
It's the difference between asking a student for the answer and telling them they have to show their work using specific resources.
That's it exactly. And there are 3 non-negotiable instructions in that meta prompt.
Okay, let's break them down.
First, the custom GPT is told to generate an initial chain of thought, a COTI. This is its raw internal thought process based on the user's query and its general knowledge. Think of it as the first draft of its reasoning.
The unedited brain dump.
Yeah.
What's the check on that?
The check is the second instruction, and it's the most critical one. The mandate to reflect and augment. The LLM has to immediately pause and verify, enhance, and correct its raw chain of thought using those static documents we built.
So it has to check its own work.
It has to check its reasoning against the specialized knowledge from the anchoring agent, the logician agent, and the cognition agent. It's a mandatory self-correction loop.
It's forced to check its own assumptions against the high-quality information we engineered in step 1.
Precisely. And only after that internal reflection is done does the third instruction kick in. Conditional dynamic retrieval. The custom GPT is explicitly told to use the step 2 ActiveRAG action only if its self-reflection proves that the static knowledge isn't enough.
So only if the information is too new or too niche for the documents we created.
Yeah.
That level of self-awareness, generating a thought, reflecting on it with specialized knowledge, and then deciding if it needs to look outside. That is genuinely transformative for AI stability.
It changes the LLM from a parrot that just repeats retrieved text into an actual disciplined reasoner.
So if we zoom out, what's the big strategic impact here? What does this 3-step process deliver for people building these solutions in the real world?
The core benefit is predictability, and predictability translates into trust. ActiveRAG consistently gives you higher quality, more robust answers, and it dramatically reduces hallucinations.
And that's critical for high-stakes domains.
For anything in finance, legal, specialized manufacturing, anywhere accuracy is non-negotiable, this gives you a path to a production-ready system without the insane cost and complexity of fine-tuning a whole custom model.
Okay, but we have to talk about the trade-off. This sounds expensive, computationally. If simple RAG is one API call, how many are we talking about here?
It's the necessary cost of quality, right? With ActiveRAG, you are making basically 3 API calls for every complex query.
3.
One for the initial chain of thought, a second for that knowledge review and reflection step, and then potentially a third for the final answer generation.
So you're looking at roughly triple the cost and more latency compared to a simple RAG call. That's a big pill for an engineering team to swallow.
It is, but you have to weigh that cost against the cost of an error. In a financial modeling app, a 5% accuracy gain and a huge drop in hallucinations prevents costly mistakes, maybe even regulatory fines.
The investment in quality is justified because the model isn't just guessing anymore.
It's operating on engineered, validated knowledge. The cost of failure is much, much higher than the cost of complexity.
That's a great way to frame it. Pay for complexity now or pay for failure later.
Exactly. And, this trend is changing the kind of skills you need to build these things. You're not just a prompt engineer anymore.
You mentioned the term cognitive engineering. What does that actually mean?
It means that engineering your source data becomes, in a way, designing the LLM's curriculum. You are building those 3 foundation documents, the anchoring, logician, and cognition agents, to specifically teach the LLM how to reason inside your world.
So you need to understand how the models learn.
You have to understand how they learn, how to structure truth, and how to spot the cognitive gaps that lead to failure. It's a totally new layer of specialized knowledge design.
That's the perfect way to sum this up. We're moving away from passively feeding data to a black box, and toward actively teaching concepts and defining how it should reason. ActiveRAG really seems to prove that this combination of structured knowledge and a self-aware reflective process is just fundamentally better than trying to perfect the retrieval of raw text.
It's the difference between memorization and real actionable understanding.
So here's the final thought we want to leave you with. If an LLM is now required to generate its own chain of thought, reflect on it using engineered knowledge, and only then decide if it needs to seek out external data, what does this new level of disciplined self-awareness imply for the future of AI design? And maybe more importantly, what new responsibilities does this put on us, the cognitive engineers, who are now essentially designing the very architecture of artificial understanding? We'll see you next time.